All right, so question 6. These types of questions, and I kind of talked about this, I think, yesterday or the day before. When you have multiple triangles, you're going to want to start in the triangle that you know the most about. Okay? So, obviously, there are 3 triangles up there, but the overall triangle is not a 30, 60, 90 or a 45, 45, 90. We've got this triangle here, and we've got that triangle there, right? Which one do you know the most about? The 45, 45, 90, right? Here, and when I say what you know the most about, we're talking about the number of side lengths that you know. In the blue one, you know the hypotenuse. In the purple one, you know absolutely nothing. Okay? So we're going to start in the blue one. All right? And it's always a good idea. Okay? So I recognize I'm going to start in the blue one. So I should probably have in front of me my 45, 45, 90 template, which looks like this. Says 45 degrees there, 90. This would be in, this would be in, and this would be in radical 2, right? So if I take that picture and lay it on top of the blue triangle, do you see that and that will equate to each other? Okay, so I get the little equation that n radical 2 is equal to 3 radical 2. Now, equation-wise, this is a 1-to-1 correspondence, so what does n have to be? N has to be 3. So in our template, n is that side there, right? So up here, C would have to be 3. Is that all right? For the same reason, what's A going to be? A is going to be 3 as well. Now, doing that, have we now worked with this triangle, found enough values that allow us to kind of fall into this triangle and now deal with parts that are in this one? Okay. So once I'm in that triangle on the right, now I'm going to draw my template for a 30, 60, 90. And I'm going to try to draw so that it's, congruent to the 30, 60, 90 in my picture. That's 30, that's 60, obviously my 90. We know across from the 30 is always your n. Okay? And maybe because I've already used n and I don't want you to get confused, maybe I use m. Can I do that? Yeah, and this would be 2m, and this would be m radical 3, right? It doesn't really matter what that variable is. Change it if you want to eliminate confusion, that the n that I find in this triangle is not the same, maybe always, as the n that I find over here. Sometimes they will be. But if I put this blue triangle on top here, don't we see that those two things line up, match up? So in my template, m is going to be 3, right? So what would 2m be? This would be 6. Transfer that up to my picture. That's the distance for B. What is this distance here going to be? 3 radical 3. Transfer that up. That's going to be my D value. And now you've got those 4 values. You can plug them in. Eventually, what they're going to ask, let's say if I call that A and I call that B, they want the length maybe of AB eventually. How do I add those two numbers together? Can I do anything with this? Can I simplify that? No. That is the distance A to B. That's how we would write it. 3 plus radical 3. Okay. So that's something we can do? Okay. A lot of your questions, I'm going to give you another assignment today. A lot of your questions are these types of figures where they're stacked on one another, okay? Whether they be 30, 60, 90, all of them are 30, 60, 90, maybe a combination of 45, 45, 90, 30, 60, 90, or all 45, 45, 90, okay? And that's the kind of process you want to go through. 13? Yep. Okay. Since a triangle is in the shape of a 30, 60, 90 right triangle, it says if the hypotenuse of the outer triangle is 33 feet, find the lengths of the legs of the triangle in inches. Okay. So they give you this. Say again. 12? Okay. Does anybody want to do 13? We can.
No, please, can we do it?
Yeah. Yeah. I don't really like the picture. That I don't know why they do this, but yeah, that inner triangle doesn't mean anything to you. They're talking about this distance here being 33 feet. Okay, 33 feet. So if I go through my work here, this is a 30-60-90. So if I draw a 30-60-90 template, obviously my 30 degrees has got to be up here, right? So now this would be in. 60 is here. So that's in radical 3. And my 90 is going to give me 2 in, correct? Okay. If we match these up, do we see that 33 and 2 in are going to match up? Okay, so I'm going to say 2 in is equal to 33. And then is 33 over 2. Okay, I'm just going to leave it that way for now. And that's feet, right? Now the question is, can we find, I think it said both side lengths, both legs, in inches. So right now I know this is 33 over 2. Wouldn't this side here be 33 over 2 times radical 3? That makes sense, everybody? Okay. But these are all in feet. Okay. I want my answer in inches. So what do I need to multiply things by so that I get it in inches? 12. Okay. So 33 feet, 33 over 2 feet. I want to multiply that by 12 inches over 1 foot. Okay. The feet are going to cancel out, right? Is that 12 and that 2 going to cancel? Leaving me 6. And the only thing left would be inches then, right? So it's 6 times 3. 18. Carry the 1. 6 times 3 again is 18 plus 1 would be 19. So 198 inches. Okay. Now let's do this. Let's say that I have, so that would be this bottom side. Okay. Let's say that I've got 30. Do the work up here. 33 over 2 times radical 3 over 1. That would be feet, right? Okay. Can I multiply, so I'll put the feet up top. Can I multiply that by 1 foot and then 12 inches up top, right? Does that make sense? Feet still cancel, correct? Okay, 12 and the 2 still cancel, correct? Okay, so what's 33 times 6? Because now what we've got, guys, is because all the numbers have gone to 1, we have 33 times radical 3 times 6. These are the best two numbers to multiply together because they're both integers. Okay, so that gives me 198, doesn't it? So 198 root 3 inches would be that side there. 198 inches would be that one there. Now, I'm going to look back to see the question. It says type exact answers using radicals as needed. So the length of the shorter side, that's the 198. And this one would be 198 radical 3. Tyler? Do what? By 6. Yeah. Because you know that 2 and that 12 are going to make that 6, right? Yeah, that's fine. But I want you to know why you can do that. Because other questions, what if I wanted to change into yards? Okay. Now it's not 6, right? So, yes, that is fine. Does that help? That triangle, not sure the purpose of it. Have you guys seen like rulers this way, kind of developed that way? They're essentially squares as well. I don't know if that's what they're trying to get at, but you said 12. Oh, it's a beautiful question as well. These beautiful questions I like to put on quizzes.
That's what we were just working on. Oh, yeah, you can get that. Well, Claire knows how to do it.
What kind of shape is that thing? It is a quadrilateral, but you can do better than that. It is a trapezoid. If we have 90 degrees here and 90 degrees there, that means those two angles added together are supplementary, right?
Yeah.
Are they same side interior?
Yeah.
So those two things have to be parallel, right? Okay. So there exists, from this point here, would you agree that there are a lot of lines that can go to that other base from that point? Would you agree that one of them is going to be perpendicular? Okay. So now what kind of triangle do we create right here? A 30, 60, 90. Okay. Now, think about this. If this is 30, 60, 90, that's 30 degrees. Okay. So when they say 12 here, guys, 12 is that entire distance. Okay. Right now, based off of that 12, I don't know anything about this triangle. But I do know something about this triangle in regards to that number there, right? Because if these two lines here are parallel, okay, and we've got then these four right angles, obviously these two are right angles, that makes these two parallel. And a parallelogram with three right angles, or actually a parallelogram with one right angle, is a rectangle. It could be a square, but most specifically, the most general way of saying it is that it's a rectangle, because I don't know necessarily whether this is going to be 3 right angle 3 or not. We'll see if it is or not here in a moment. But we do know that we can transfer that value there to that thing right there, can't we? Yeah. So now I've got my 30, 60, 90 triangle. So I'm going to draw my template so it's positioned the same way. So there's 90, there'd be 60 there, 30, here's n, 2n, and n radical 3. If I overlay that triangle on top of the yellow one, doesn't that value and that value overlay? So the argument is if these two triangles are congruent, then 3 radical 3 is equal to n radical 3. So what's n going to be? N is going to be 3. So that is n, obviously it's the side across from 30, right? So that little red distance is 3. A would be what? 6. If that's 3, the whole thing is 12. What's B? B is 9. Okay, 12 minus 3 will give me that B value. Does that help? Okay. That one, and you're going to see a lot like that. When you have a trapezoid, there's always that triangle that can be created. Now, that might not always be a 30, 60, 90. It might be, a 20, 70, 90 triangle. There's always a right triangle that you can add in there, okay, or by drawing in that segment. And sometimes, guys, you might see something like this. Let's say that I gave you something like that. Let's say this is 60 degrees, and let's say that's 45 degrees. Would you guys agree that there is a 30, 60, 90 triangle right there? And then a 45, 45, 90 triangle over there? Okay. And then this thing here is still going to be a rectangle, right? Okay. So then we've got all our parallelogram properties that would exist with that. It's going to probably allow us to transfer values from one of those triangles to the other. Okay? Because the side across from 60 and that triangle on the left is going to be the exact same value as the side that's across from 45 on the triangle on the right, correct? Okay? So that allows you to jump across into that type of trapezoid where you don't have right angles. We might see a couple of those soon. Tyler? 14. Okay. After heavy winds damaged a house, workers placed a 5-meter brace against the side at a 45-degree angle. So that's talking about this bottom brace. Then at the same spot on the ground, they placed a second, longer brace to make a 30-degree angle. So that's up here. Says complete parts A through B below. So it says how long is the longer brace? So they want to know essentially how long is that bigger hypotenuse. Okay. And once we answer that, we'll go through and see what else they want. All right, now in order to figure out how long that longer brace is, we need to be able to figure out something about that triangle. Okay? And if we look at this, we know nothing about that right triangle right now, correct? Okay? But we do know something about that triangle, right? I'm not very good at coloring. We do know something about that triangle. Would you guys agree with that? And it's a 45, 45, 90. So if I can take that hypotenuse and determine that side, which would be identical to that side in a 45, 45, 90, right? And once I have this side, is that side part of this bigger blue triangle? And will that then allow us to work our way through and find the remaining parts of that bigger triangle? Okay, so I'm going to start. I'm just going to draw off to the side the smaller 45, 45, 90 triangle. Okay. We know in a 45, 45, 90 that's in, and that's in radical 2. Right now that they're saying our in radical 2 side is 5, correct? Can I do the work to solve for n?
Yeah.
Okay. So n ends up being 5 over radical 2, correct? Okay. Now that's not the answer. I'm just going to do this right now. I'm just going to write n. So this distance here, you can rationalize if you want to. I'm going to see if just leaving it this way and doing my work beyond that stage is going to allow me to kind of by default rationalize it. I'm not really sure, but it doesn't really matter whether you do it now or later. So now you know in a 30, 60, 90 triangle, so this is the longer brace, okay? So this would be your 30-degree angle up here, and this is going to be your inside. Well, let's use a different variable. Let's say this is your m side. This is 2m, and this is m radical 3, right? They want to know how long is your brace, okay? Well, if I put these two triangles, I put this triangle here on top of this blue one over here, doesn't m match up to 5 divided by root 2? So then what do I have to do in order to get m as my, or what do I need to do with m to find my hypotenuse? M is 5 radical 2. To go from m to 2m, don't you put a 2 right there? So keeping a balanced equation, don't I need a 2 here? All right, so I'm going to double 5 over radical 2, which becomes 10 over root 2, right? Does that make sense, everybody? Now, in the event, now I know the question doesn't ask, I think the question says decimal or whatever. If it just wants a decimal, I could type 10 divided by radical 2 and get that, okay? But I think it's good for us to practice rationalizing. So multiply by radical 2 over radical 2 gives me 10 radical 2 over 2, which that reduces to 5 radical 2. So 5 radical 2 is that hypotenuse there, which is going to mimic then, it is the hypotenuse here of this blue triangle. It's the longer brace. So using my calculator, because that's what they want us to do, can we change this to a decimal? I'm going to kind of encourage you guys as you're at home, when you have to convert something to a decimal, or whenever you're using your calculator, start using this calculator, okay? Don't use the handhelds. Don't use the one that we got downloaded on the computer. Go to desmos.com, okay, DESMOS, and start using this computer or this calculator and get a comfort level with it, because April 16th, when you take the end of course exam in here, that's the version of the calculator that you're going to be using, okay? So I want to be nice to be pretty good at that, okay, and understand how to navigate through and use it. So that being said, we're also, the next couple sections, I'm going to force you to use this in class because we need these buttons, okay, sine, cosine, tangent, which will be nice, okay? So I'm just going to type in 5. Now you can use these keys down here, obviously, just like a normal calculator, but it also has kind of shortcuts. If I type in the phrase SQRT, it'll automatically put that in there, and I want it to. So 7.07 is what we're looking for here, and they say type an integer or a decimal, round to the nearest tenth as needed. So we had 7.07. That's my tenths place, right? The 0. So what do I round to? 7.1. Okay, so get back here, type in 7.1. Obviously, that makes sense because this was 5. We know this is going to be longer. Okay, that answer makes sense. You know, it's not going to be, you know, this 45 and this 30 are not drastically different, or the 45 and the 60 down here are not drastically different. So I know that my answer is not going to be like 30. Does that make sense? It's going to be close to 5. And it says, how much higher does the longer brace reach than the shorter brace? Okay, how much higher? What that's asking for is that distance right there. Does that make sense to everybody? Okay. Well, we went through the work of saying that this, actually let me go back to this. We know that this distance here, that the short brace reaches on the house is 5 over radical 2, and we know then over here that this one here should be this distance times radical 3, right? So I'm going to write this as 5 radical 3 over radical 2, okay? Those two distances, if I do what with them, will give me that red distance that I'm looking for. I have to subtract them. Which one's going to be bigger? 5 radical 3 over radical 2 minus then 5 over radical 2. If you can't determine which one's bigger, but you know they're asking for a distance, just subtract them and take the absolute value, right? And I'll give you a positive distance. Now, I'm going to do some work here because I think it's important that we understand how we can do this by hand, because I don't know on the end of course exam, maybe they ask you to write the exact answer, okay? So let's see if we can do this difference. I don't like the way either of these are written because they have radicals in the bottom, right? Okay, so I'm going to rationalize both of them. I'll kind of do that individually here. 5 radical 3 divided by radical 2. I would multiply by radical 2 over radical 2, right? That's going to give me 5 radical 6 over 2, correct? Okay. Then I've got the 5 over radical 2. I'll rationalize that. And it gives me 5 radical 2 over 2. So now I'm going to subtract those things, right? Okay. They have the same denominator. That's good. So I got 5 radical 6 over 2 minus 5 radical 2 over 2. Can I subtract those the way they're presented? No. Why? Those two numbers have to be the same in order for us to subtract, right? Okay. Now you can do this. Because they have the same denominator, you can write it this way. 5 radical 6 minus 5 radical 2 all over 2 if you want. That's an option. Or, okay, this 5 radical 6 over 2 is the same thing as 5 halves times radical 6 minus 5 halves radical 2. What do they both have in common? So this is okay. This is okay. This is okay. What do these two things have in common? If I factor 5 halves out and get radical 6 minus radical 2, that's okay. Those are all various versions of an okay answer. Does that make sense? And that's why we learn all the math rules and algebra that we do, because what if I'm presented with one of those and I want to maybe transform it and say, okay, I don't like the way it looks here. Can I write it some other way? Maybe writing it another way would be beneficial to me in some aspect. If you understand that you can do that and how all these different kind of versions appear and are all still the same value, you can do that. All right. A lot of times like you guys are going to eventually, a lot of you are going to take college algebra, trigonometry. Okay, that's kind of the course that you are on right now, the path that you're on right now. When we use a program called WebAssign, WebAssign will accept any one of those 4 versions. But if you were to answer it wrong, WebAssign is going to give you feedback that is aligned with that last version. And what I need you to understand in that class is, well, that last version, if you distribute 5 halves through it, it gives you the one above it. If you use your rules of adding, subtracting fractions, it gives you the one above that, right? Does that make sense? Okay. So feedback, or the way I read something in a textbook, if I understand the various ways it can be written, I'm not going to get confused when one author changes their format over another. Okay. Now typing this in, this is another reason that I think a lot of you are going to like Desmos, is if I do 5 halves, okay, and then square root of 6 minus square root of 2, that was what we had, right? Yeah. Okay. It tells me, or it puts it, we call this latex. Okay, that's the kind of the math print. It shows me how I would have written it by hand, doesn't it? Okay, where your TI-83, TI-84, okay, these calculators, they do not do that. The little red ones that I have, or the little blue ones that you guys have, don't do that. And that actually ends up being a big reason why some people miss questions, because you can't type in the way I see it written the same way on a TI-83. You got to understand how this thing navigates the order of operations. So I get that number, and just to prove to you that that's the same thing as, if I go 5 square root of 6, okay, then I'll hit divide by 2. Is that the same thing as 5 square root of 2 divided by 2? Gives me, I know some of you might not be able to see, but those two numbers right there, those two decimals are the same thing. Okay. And if I go 5 square root of 6 minus 5 square root of 2, put that parenthesis in, now divide the whole thing by 2. So you're seeing here now, guys, that that's how I would have written it, right, by hand. This calculator does not do that. But you see that when I evaluate, it still gives me that 2.588. So these are all three adequate, perfectly fine versions of that answer. Okay, so they want to round to the nearest tenths. So tenths place right now is 5. The number after that's 8. So it tells me to go to 2.6. So it reaches 2.6 meters higher than the 5-foot bridge. Now, I typed all those things in at the same time on my calculator. If your person says, I want to find out what 5 radical 6 divided by 2 is, store that number, write it down, and then do the same thing with 5 radical 2 over 2, store that number, write it down, and then subtract those decimals. That's fine. But if I were to round both those intermediate values to one decimal place, I'm probably going to screw up my decimal for my answer. Does that make sense? So if you're going to do that, you're going to want to round to 2 or 3 or 4 decimal places, and then subtract them, and now it won't create compounding error for your answer.
Okay. If I ask more, when I rounded this to 1.7.
It's little because there's rules, and maybe you know this thing. That's a 5. Okay, because of how you round. If you round at 5, you round up, right? So 5, 6, 7, 8, and 9 you round up. But 0, 1, 2, 3, actually not 0, but 1, 2, 3, 4 we round down. So 44% of the time we round down, 55% of the time we round up. So to compensate for that, it's not 50-50, it's usually 50-50. There's rules that say, based on that being an even number, it's half time B, half time we got. Even numbers, we round it up. Odd numbers, not a residence. It's pretty complicated. And I've never memorized it, but that probably won't be. Don't worry about that.